How does division work? We talked about this last class. On Tuesday, we worked a division problem using all three methods. And we did a bunch of stuff with dealing out cards around a table. So if you were here, you'll remember that. But that was a tool to help understand things like long division. So the numbers we used are pretty big, like 972. So we're going to now focus, even with some small numbers, on just reinforcing how division works. So I want 12 divided by 4. So I have a card. Let's say we have 12 cards in our hand. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have all of these in my hand. And I want to divide them up among 4 people. So let's get a table. And there's 4 people sitting at this table. And each person is going to get some cards. Pardon my tiny stick figures. I am not up for trying to draw pictures of 4 people sitting at a table. Okay, here we go. So you get one, you get one, you get one, you get one. We've gone around once. Let's do it again. You get one, you get one, you get one, you get one. We've gone around again. Ta-da. If we were in person, I could really deal out cards, but for now we see it here. At the end, everyone has 3 cards. So the answer to 12 divided by 4 is 3. Everyone okay so far?
Yeah.
Yeah.
So let's model that again with 972 divided by 4. If you were here on Tuesday, this is a little bit of a repeat, but if you weren't, then here's a chance to see it. So I have my table, and I need 972. So here's 100. 2, 3, 4, 5, 6, 7, 8, 9. So there's my 900s. I need 70, 10, 20, 30, 40, 50, 60, 70. There's all my 10s. And then I have 2 1s. Okay, so I have 972. Now I want to deal it out to the table. I'm going to move my 2 kind of out of the way. Everyone ready?
Yeah.
So everyone gets 100. Let's start with the big numbers. Can I go around again with hundreds?
Yeah.
Yeah, everyone gets another 100. Can I go around a third time with hundreds?
No.
No, I only have 100. So this person could get one, but no one else would. So I'm going to take this 100 and say, let's think of it as tens instead. So goodbye 100, you're gone. And instead I'll have 10 tens. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've gotten rid of this 100, bye-bye, and made 10 tens out of it. Now I can start passing out tens. So let's go around once. We'll go around again. Oh, that's a good thing I made some change, because then I can keep going. Let's go around again. Can I go around another time?
Yeah.
Yeah.
But now I'm down to a single 10. So again, one person could get it, but I can't get all the way around the table. So let's break it up also. So instead of a 10, let's have ones. Goodbye 10, nice seeing you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we'll deal out one at a time. and I run out of cards. So what's the answer going to be? Oh, let's spread them out and see. So how many cards did each person get? 10. It looks like 243. If you want, check on a calculator. Everyone okay so far?
Yeah.
What we did the other time was do that same sort of dealing when writing long division in the traditional way, or when writing long division using the line method. And we were sort of sliding this thing down as we went. So if that helps you, go back and look at the videos from last time. I'm pretty sure we recorded this. But okay, but back to today. Now the warm-up we just did had a fraction. Imagine I baked 6 pounds of brownie, and after I made it, I cut it into half-pound pieces. How many pieces do I have? The picture was this one. I have 6 pounds of brownie. Imagine, if you want, that I cut them up into 1 pound pieces. 1, 2, 3, 4, 5, 6. But that's too big a serving. If you ate a pound of brownie at a time, you would feel very bad. So we'll make it only half-pound pieces because we're pretending that that's a better serving. How many pieces do you have? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If you watched our last ToDoodle, then that was among all of the different pictures, that was the shattering things into pieces is division. I want 6 things. I have 6. I want pieces of size a half. Ah, I get 12 of them. How do we do that with cards, though? I can't deal out cards to half a person. Even if I could, like, take my friend here and take some sort of samurai sword and slice him in half. After that violence, I wouldn't know what to do. I still can't put like half a pile somewhere. That just doesn't make any sense. So it seems like we can't deal out cards to half a person that way. We need some other way to think about it. So we need a different way to think about division. And if you haven't been shown this way, it's not your fault. It doesn't mean you're not smart. It just means your teachers before that were teaching you division didn't do a good job. So you can be mad at them. So let's do 6 divided by 3 using both models. So I have a card. I want 6. 1, 2, 3, 4, 5, 6. I have 6 cards in my hand. Now I want to deal out cards first with what we did. I want to make piles the size, I'm sorry, as many piles as this number. I want 4 piles because that number is 4. So method 1. Is the other number is how many piles? How, there we go, many piles. Okay, let's make 3 piles with these cards. There, 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 there. So what's 6 divided by 3?
2.
2. And where is 2 in the picture? It's how many each pile got. Everyone with me so far?
Yeah.
Okay, so the other way I could do this, let's rewind time. Pretend we didn't do that. Method 2, now that divided by 3, the 3, the other number, is going to be the pile size. So I'm going to make piles of size 3, because the other number was 3. So here we go. 1, 2, 3. 1, 2, 3. The answer is still 2, but where is the 2 now?
The amount of stacks.
Amount of stacks, yeah. So whichever method I pick, the answer is the other thing. If I say that the 3 is how many are in a pile, the answer is how many piles I get. If instead I dealt out my cards to 3 piles, whoops, 1, 2, 3, 1, 2, 3. Now the 3 is how many piles there are. Now the answer is how big is the pile, the size. Does that make sense?
Yes.
So we're going to do this now, not with whole numbers, but with halves. So here I have a playing card. Can I do this one? Can I make only half a pile? No, because a pile by definition is at least one thing. So this method isn't going to work. But this one does work. Let's make piles of size 1/2. So we're going now to do 6 divided by 1/2. And we're going to make one half is the pile size. So I take my scissors and I cut my playing card in half. But before that, I need 6 playing cards. So 1, 2, 3, 4, 5, 6. And I take all these playing cards and cut them in half. And that's how big a pile is. So go ahead and do that. Take your mouse and make piles of size 1/2 with all these playing cards. Yay, okay. Yeah, everyone see how that looks like this picture, the 6 divided by 1/2, taking 6 and breaking it into pieces of size 1/2, and you get 12 of them. We broke the 6 things into pieces like that. So the answer was how many piles? There's 12 if we count them. And this helps you with dividing by 1. Why is it true that any number divided by itself stays the same? Because if I make piles of size 1, I get the same number of things I have. How come dividing by 0, whoops, that should say D, dividing by 0, how come that acts like infinity? Because if I make piles of size 0, I'm not putting any cards down on the table. I just have a stack of my cards in my hand forever because I'm not really putting them down. Okay, we're going to take a break because it is 7. And when we come back, then we'll try doing these with either dealing out cards. The other number is how many piles we're making because we're dealing cards to people, or the making piles of a fixed size. The other number is how many are in each pile, but that's later. So let's take a little break and come back. Welcome back. We've done some work after our break. We started by looking at the first problem. 378 divided by 2. When we wrote it the first way, we did it a very traditional way. That was the request. How many times does 2 go into 3? Once. And then 3 minus 2 is 1. Bring down to 7. How many times does 2 go into 17? 8. 8 times 2 is 16. Subtract. We get 1. Bring down the 8. How many times does 2 go into 18? 9. And then that's 18, and there's nothing left, and we're done. The answer is 189. Last class on Tuesday, we talked about what happens if you put the zeros in so you could really see the place value instead of having the arrows that save time when we write, but they do make it harder to understand what's actually happening. So I'm going to redo this one with the zeros instead of the arrows. Okay, here we go. First, I'm going to think about 100 at a time. How many times can I deal out 100 cards to 2 people sitting on opposite sides of a table when I have 378 cards? They each only get a stack of 100 once, because 100 times 2 is 200. And then that's all I can do with stacks of 100. At that point, I still have 178 cards at the dealer's pile somewhere. Now I'm going to deal out 10 at a time. If I deal out 2 cards 10 at a time, how many times does each person get 10 cards? 10 for you, 10 for you. A second 10 for you, a second 10 for you. Now we're up to 30 for you, and 30 for you, and so on. And the answer will be that both people will get 80 right? 8 stacks of 10. That will use up 160 cards. And what's left is 18 cards in the dealer's hand. And then we go down to ones. If I say 1 for you and 1 for you, 1 for you and 1 for you. How many times can we deal out to 2 people 18 cards? That will be 9 times. And then they have 18 more in front of them, and the dealer is out of cards. So to emphasize, you don't have to be able to reproduce long division fluently, as far as I know, on the GED. I don't think there is a long division problem on the GED. We're explaining this with dealing out cards and putting the zeros in case either now or after you watch the recording a little more, or maybe watch the other recording we made up here, that if you can understand why a long division works, because we're talking about dealing out cards and putting the zeros in that people left out, then you can say, yay, I am smart. My brain works great. I can understand long division, which is pretty complicated. If I couldn't understand it before, it's just because my teacher didn't explain it well. That wasn't that somehow I'm not able to understand long division. So this is to make you feel smart, not to say, practice lots of long division. We also did a contrast. If I want to say how many times does 2 go into 8, I could write that as long division, but the long division doesn't really help. I know the answer is 4. 2 times 4 is 8, and there's nothing left. So this is more just about recording the answer than I'm actually using long division to get the answer. And that's because what long division does is think about place value for you. I don't have to think about this being 300 and this being 200 with the arrows, right? The 100-ness is missing. I don't have to think about this being 70 and this being 160 with long division. The arrows hide the place value. But if there's no place value, long division doesn't do anything for you. It just is like an awkward way to write the answer instead of putting a 4 on the paper. With fractions, it's the same thing. I have 8 cupcakes, blue cupcakes. I want to give each kid at the birthday party a quarter of a cupcake because they're small and that's all they get. How many kids can I give? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Go all the way through. There'll be 32 little pieces. I can write that as long division, but it doesn't help. I had to find out the answer being 32 with my picture before I put something here and said, yes, that uses up all 8 cupcakes. There's none left. Long division is just an awkward way to record the answer, just like here, which is why we don't use fractions with long division. It's just a way of writing. It doesn't help us solve the problem. So that was this one and this one. What if you wanted to do 36 divided by 4? Let's talk about something else. So we said, imagine a student that, if you're like a teacher's aide at a classroom where people are learning long division for the first time, and this student says, I'm going to do 36 divided by 4 by counting by 4s. 4, 8, 12, 16, 20, 24, 28, 32, 36. I got there. So what is that? Then they go back and write the red numbers: times 1, times 2, times 3, times 4, times 5, times 6, times 7, times 8, times 9. It's 9. 9 is the answer. 9 4s is 36. Is that a dealing out cards kind of thinking, or a making piles of a fixed size kind of thinking? And we talked about it and agreed it was making piles. It's like the person had 36 cards in their hand. Here's a pile of 4. Here's another pile of 4. So now 8 are on the table. Here's another pile of 4. So 12 are on the table. And when we run out of cards, there'll be 9 piles of 4. We haven't done these yet. I'm going to pause the recording and see if we want to do them now or save them for homework or whatever.